Well, welcome advanced algebra students. Looks like it's time for our first video of the new week. And so we're going to stick with 14.1, our second day in 14.1. We're going to do using trig identities. So a little bit more on using them. So what this means is, since it is 14.1 again, we are talking about using the trig identities. I gave them all to you last time. So they're all in the previous notes, so we don't have to worry about giving you the identities again. I might suggest you go back and you re-look at them and remind yourself what they are, but we're just going to be using them today. So the only notes that we have is some strategies. So you're going to be asked to simplify, and I'm going to give you a couple strategies that will help you with your simplification. So first thing, use Pythagorean identities whenever possible. Now, the key to knowing when to use a Pythagorean identity is when you see that, in particular, you have something squared plus or minus something. Then you think Pythagorean identities. Anytime you see something squared plus or minus something, that's when you tend to think of using a Pythagorean identity. Now, when using Pythagorean identities, don't forget that you can change the form of the Pythagorean identity. And what do I mean by that? Let's look at an example of what I mean by that. So for instance, here's our most basic Pythagorean identity. Sine squared plus cosine squared equals 1. Well, while it is true that if you have sine squared plus a cosine squared, you can replace it with 1, don't forget that you can also change the form of this. Like for instance, if I wanted to go here and I wanted to subtract the cosine squared of x from both sides, then that would take it away from here, and I would have 1 minus the cosine squared x over on there. So I know the sine squared x would also equal 1 minus cosine squared x. So if you see this, remember that it's not exactly this, but you can change this so that you could replace this with the sine squared x. So keep that in mind. Here's another example. Here's another one of our Pythagorean identities. 1 plus the cotangent squared x is equal to the cosecant squared x. Well, I could go ahead if I wanted to, and I could move this cotangent squared over to the other side, and I could say 1 is equal to the cosecant squared minus the cotangent squared. So if you see this, you could just simply replace it with 1. So remember, there's the basic Pythagorean identities, but then you can also manipulate them by moving things around from side to side. And then finally, really the most common thing that you do is change everything to sines and cosines and then cancel out and simplify where possible. That's probably the most common thing to do. All right, let's go ahead. Let's take a look at some examples and let's see how to do this in action. The notes really won't be very long today. So our first example is number 29. So we are given the cosine theta plus the sine theta times the tangent of theta. And they say to simplify this, and what it really means is we should be able to simplify it down to just a single trig function. Just a single trig function is what we want to do. So in this case, I don't see any squareds. I do see a plus sign, but there's no squareds or constants. So I'm not going to think Pythagorean identity. I'm going to go with my last strategy there, change everything to sines and cosines. So here I already have cosine and sine, so they don't change at all. But instead of the tangent, I'm going to change that into the sine theta over the cosine theta, just using my quotient identity. Now as I look here, notice what I've got is, simplifying that down, I've got the cosine theta plus, and notice this sine theta times this sine theta gives me a sine squared theta. So I still don't have a single identity. And the problem is here, I have to add these two up. In order to add up a fraction and something, I need a common denominator. So I need a common denominator, the cosine of theta. So I'm going to have to multiply this by cosine over cosine to get my denominator to be cosine. So when I multiply the top by cosine, I get cosine squared, and the bottom is just cosine. There's my common identity. Here, cosine's there, sine squared. But notice what I have here, cosine squared plus sine squared. That's equal to 1. So that's 1 over cosine squared. Now just changing that using my reciprocal identity, That is just the secant of theta. So 1 over cosine theta just equals the secant of theta. And I'm done. Let's look at another one. So here's number 40. Number 40, we have a sine squared times a cosecant theta times a secant theta all over a tangent theta. And at first we see we have a sine squared, so we might tend to think we want to use Pythagorean, but really we don't, because we don't have this plus or minus anywhere, so there's nothing that I could do that's really going to make that simpler with that. So I'm just going to go and change everything to sines and cosines. So doing that, sine squared is still going to say sine squared. Cosecant is going to be 1 over sine, and secant is going to be 1 over cosine. And then the denominator is going to be sine over cosine. Now the truth is, some of you might be able to look at this and know what to do. You might recognize, well, I'll cancel this sine with one of these. That gives me 1 sine over cosine. So I've got sine over cosine over sine over cosine, and you might see that that equals 1. But a lot of us will have to work it out a little bit further. So canceling this sine with one of these sines, I get sine over cosine for the numerator and sine over cosine. But anytime you divide by a fraction, you multiply by the reciprocal. So I have sine over cosine times the reciprocal cosine over sine. Here it is easy to see that everything cancels out, and I just have 1. Last example, we're calling this example A. It's not particularly in your book. It's one that I created. So here we see a classic example of when we want to use a Pythagorean identity. Notice we've got this 1 minus cosine squared. Now we recognize that's a constant. It's like I said, we think constant plus or minus something squared, we think Pythagorean. Now this is not a direct Pythagorean identity, but it is one of the ones that we looked at that can be altered. 1 minus cosine squared is equal to the sine squared. So I can go ahead and change this to the sine squared, and I'm changing this to sine over cosine. So this gets replaced by sine squared, this tangent gets replaced with sine over cosine. Notice here, the cosines cancel, and I just get sine squared over sine. So this sine cancels with one of these, and I just have sine of theta. Okay, that's what you're going to be doing. Homework is 14.1, 30 through 39 all. Hope that goes well, and we'll have a new video for you tomorrow.